In this video, we are going to be taking a look at the second half of NJC 2021 H2 Math Prelim Paper 1. And we have done question number 1 to 7 in our previous video. So today in this video, let us take a look at question number 8, which is this question over here. So we are given this curve C, where curve C has this equation. It is x squared plus xy plus ay squared. This is equal to 36, and a is a constant. A is also going to be bigger than 1/4. In part 1, we are supposed to find the x coordinates of the points on the curve C such that the normal is parallel to the y-axis. The normal is parallel to the y-axis. I think just to make sure that we understand the question correctly, let's try to do a quick sketch of the scenario. Okay, so we are looking at a curve such that its normal is parallel to the y-axis. So we are looking at a situation that is like this. Let's say this is the y-axis here. So the normal is parallel to the y-axis. That will mean that the tangent is going to be parallel to the x-axis. So at such points, dy dx will be equal to 0. So in order for me to find the x coordinates of these few points, we are going to find dy dx first, and then letting dy dx be equal to 0. Then you will help us to work on points where the normal is parallel to the y-axis. So let's try to differentiate this with respect to x. So it will be 2x plus product rule for this. It is going to be x dy dx plus differentiating x is going to be 1 times y is equal to differentiating this implicit differentiation. This is going to be equal to 2ay dy dx is equal to differentiating 36 is a constant. So we are going to be having this. We are going to make dy dx a subject. So this and this, I'm going to combine them together. This gives me x plus 2ay multiplied by dy dx is equal to, I'm going to shift this over to the right hand side. So we have a negative of this plus this. So 2x plus y. So dy dx is going to be equal to negative of 2x plus y over x plus 2ay. And we are going to be finding the points where the normal is parallel to the x-axis, which means that we are going to be letting dy dx be equal to 0. So letting this be equal to 0, negative of 2x plus y over x plus 2ay is equal to 0 is the same as having the numerator to be equal to 0. We are going to be finding x. So I'm going to make y the subject here. Y is equal to negative 2x. So for points that are like this, it is governed by two relationships between x and y. One is this, the other one is going to be this. So in order for me to find the actual points, I just need to solve these two equations here as simultaneous equation. So let's substitute this equation into here, which will then give us x squared plus x times of y, it is minus 2x plus ay, which is minus 2x squared. This is equal to 36. So if I were to combine, it's x squared, x squared, x squared. So if I were to combine the left-hand side together, we have a 4a minus 1 of x squared. This is equal to 36. So x squared is going to be equal to 36 over 4a minus 1. So x here is going to be equal to plus or minus 6 over square root of 4a minus 1. Okay, this is done. And for part 2, part 2 we have a very, very strange graph over here. And this graph is actually based on curve C. So for this graph, a is equal to 5 over 2. Okay, a is equal to 5 over 2. There's something interesting to take note of, which is actually here. When a is equal to 5 over 2, x is going to be equal to plus or minus 6 over square root of 4 of 5 over 2 minus 1, which is going to be plus or minus 6 over square root of 9. So 6 over 3, this is going to be plus or minus 2. So one of the normal is actually x is equal to minus 2, which is actually reflected here, this line here. Okay, this is the line x is equal to -2, which means that if this is the normal, I mean, I can see from the graph, okay, that it is supposed to be normal to this part of the graph, not this definitely. So the tangent here is actually going to be parallel to the x-axis. This is actually interesting, although it is not directly, may not be directly going to be helping us to come up with the question, but we do want to take note of that this point here is specially set up so that we can then subsequently find the volume when this region R that is described by the question and then shaded by the diagram, when this region R is revolved about the y-axis. Because what we are looking at is a non-function graph with respect to the y-axis. So we are going to be using integration to try to find this volume. But when we are using integration, the expression that we're using within the integral must be a function. Okay, which means that if I were to be just looking at the equation that describe this entire graph with respect to the y-axis, since a horizontal line can cut it at more than one point, it is not a function with respect to the y-axis. So the equation here will not work. By setting up a question that is like this and making sure that x is equal to -2 is the normal to the graph, we can actually try to break up this equation into parts so that a portion of it will become a function, so that if I were to be starting from here, if that graph can start from here, okay? If the graph can start from here all the way until the rest of the parts, which we are not very sure where it is probably going to be based on the hint that is given to us here, then we will actually be getting a function, a graph that is going to be satisfying the horizontal line test for a function that is with respect to the y-axis. Okay, but anyway, that is just some blabbering by me about an interesting information that I see. But let's just see how we can solve for this question here, okay? So let me just draw the graph. So we have the y-axis here, and we have an x-axis here. Okay, I'm going to draw this properly so that this is actually a normal to this particular point here. So let's say it is going to be something that is like this. Okay, then making a turn, then coming back down. Okay, it is going to continue. It is like an ellipse, but sort of like slanted kind of ellipse. So we have this. So at this particular point here, which is the maximum point to this graph, we have this vertical line down. And this is where x is equal to -2 is. Okay, it is a normal. So we do know that if I were to draw a horizontal line here, it is going to be 90 degrees to this. Okay, so this shaded region here is the region R. This region here is going to be rotated with respect to the y-axis. So there are a few things that we need to know. We need to know the equation of this. Not using this, because this is not a function. So we need to know the equation of specifically just this with respect to the y-axis. So one of the first things that we can try do is to make x a subject first, based on the equation of curve C that is given to us. So based on this equation here, I'm going to try and make x a subject, okay? So we have x squared plus, I'm going to see this equation as a quadratic equation in terms of x. So y I'm going to see as a coefficient. So let me just put it in front so that it is of a form that we are sort of like a little bit more familiar with. And this will be the term that is independent of x. So to make x a subject, we are going to make use of the quadratic formula. So it's going to be minus b plus or minus square root of b squared minus 4a. A is 1. A is A, so anyway, A is 1. 1, then after that c. So we have this 36. This is going to be divided by 2a. So if I were to simplify this, I will be getting a minus y over 2 plus or minus square root of. This is going to be simplified to 144 minus 9y squared. And the question told us that x is supposed to be less than or equal to minus y squared. Here we have a minus y, x is supposed to be less than or equal to minus y over 2. So here we have a minus y over 2, which means that we will be choosing a minus y over 2 minus square root of 144 minus 9y squared in order for x to be less than minus y over 2. So let me write down the reason, because x is supposed to be less than or equal to minus y over 2. And with this, we know that this part of the graph that is binding the curve is going to be this. Okay, because we are looking at a region that where x is supposed to be less than minus y over 2, x is supposed to be a region that is on the left-hand side of x is equal to minus 2. So this region here, okay, according to what the question says, is a region that is bounded by a curve where x is less than or equal to minus y over 2. So this region here is going to be x is equal to minus y over 2 minus square root of, oops, did I miss out something? I think I did miss out some things. Okay, there's a half here. So let me add it in, okay? So here, there is still going to be a half. So here is a plus or minus half. Plus or minus, I forgot about this, 1 over 2. So plus or minus half. Here, I'm going to choose a minus. Okay, so it is going to be still the same reason for my choice. It is minus y over 2 minus 1 over 2 square root of 144 minus 9y. So here is, this part of the graph is minus 1 over 2 square root of 144 minus 9y squared. So it is for this portion of the graph here. Okay, until here, this point. So now we have the curve that is binding this portion of the graph. We will also need the y coordinate of these 2 points here and also here. So assuming that we didn't make that analysis, because we do know something about this point from part 1, right? But we can also find the y coordinates of these 2 points by letting x be equal to minus 2. So if I were to let x be equal to minus 2, that means we will have a minus 2 square plus minus 2 times y plus a times a is equal to a, we actually know. A is equal to 5 over 2. So here is a 5 over 2. Then y squared, this is equal to 36. And we will get an equation 5 over 2y squared minus 2y minus 32. This is equal to 0. And this will tell me that y is going to be negative 16 over 5, or y is equal to 4. So based on the diagram that we are looking at, we can definitely deduce which one is which, because y is negative 16 over 4 should be the negative point here. So this is negative 16 over 5. Okay, did I say 16 over 4? But anyway, this is negative 16 over 5. Then the other one is 4. So here is when y is equal to 4. Let me redraw the diagram based on how I am going to carry out the integration to find the volume when this region is going to be revolved about the y-axis, because for the volume, in order for me to find this volume, I'm going to first take this region here that I've just drawn all the way to here, okay, and 2 vertical lines down to the y-axis. So for this region here, which is bounded by the graph of x is minus y over 2 minus 1 over 2 square root of 144 minus 9y squared. So this region here, okay, I'm going to first work on this entire region here. Okay, this I'm going to go for a dotted line, okay, which is this line, x is equal to minus 2. This entire region here from minus 16 over 5 all the way until 4, I'm going to revolve this region about the y-axis first to get a volume. Then I will minus away this portion here being revolved about the y-axis, this portion here. So that portion is going to be from 4 all the way until this negative 16 over 5. And we have this rectangle here where this is the line x is equal to minus 2. So this rectangle over here is also going to be revolved about the y-axis, which will be giving me a cylinder. So I'll be taking this region revolve about the y-axis, minus away this region, revolve about the y-axis. And since this region is bounded by this graph, using integration, it is going to be pi integrating from negative 16 over 5 all the way until 4 of this square minus y over 2 minus 1 over 2 square root of 144 minus 9y square. Then square this dy minus away this cylinder. So it will create for me the hollow that is in the solid that is going to be formed based on the region R being revolved about the y-axis. So this is going to be pi, the cylinder is this way, right? So the radius is going to be here, it's going to be 2. So 2 pi r square. Height is going to be 4 minus 16 over 5. So it will be a 4 plus 16 over 5. This question actually allows me to press the calculator. So I'm going to just press this entire thing into the calculator to evaluate for the volume. To 2 decimal places, the volume is going to be 542.87. Okay, this is question number 8. Let's move on to the next one. It is question number 9, where we are going to be looking at a diagram again. And that is based on this particular diagram over here. Okay, so in this diagram, in fact, we have 3 diagrams. It is the original cut, then it is going to be cut off into this figure number 2, and then it is going to be folded to this prism over here. So according to what the question says, the volume of the prism, which is going to be this figure 3 over here, the volume is denoted by V. The dimensions are going to be given to us according to what the question says. We want to find a formula for X in terms of H and A. X in terms of H and A. So if I were to involve this, I'll probably be going for Y. And in order for me to just contain everything to be just X, H, and A, I'm going to use this portion over here, the length, the width, or rather the width of the rectangular cardboard. So this A over here. And this A is going to be comprising of this X plus this distance here plus X. So for this little triangle here, let me just redraw this triangle. Okay, so for this triangle here, it is an isosceles triangle. Here is X, here is also X. And it is given to us that this length here is H. So if I were to close this, and since this is an isosceles triangle, dropping a vertical line down is going to be 90 degrees, which means that this length here, I can actually find by making use of the Pythagoras theorem, right? This is H, this is X. So by using the Pythagoras theorem, this is going to be square root of X squared minus H squared, which is going to be the same as this also, because these two are supposed to be of the same length, which means that horizontally, this length here is going to be X plus this plus X. So it's going to be X plus this, which is actually 2 times of square root of X squared minus H squared, then plus another X, which is this portion here. So X plus this plus X is equal to A. I'm going to make use of this to form for myself an equation that is in terms of X, H, and A. But what the question wants is for us to find a formula for X in terms of H and A. So this is the equation that I have already, but I need to make X a subject. In order for us to make X a subject, let's see. Okay, this is going to be 2 square root of X squared minus H squared is going to be equal to A minus 2X. If I were to square both sides, I will be getting a 4, then X squared minus H squared. Squaring this, we will have A squared minus 4AX plus 4X squared. We have a 4x squared here also, so it is going to be this. This is equal to A squared minus 4AX plus 4x squared. This can be cancelled. So now I can make X a subject. If I were to make X a subject here, okay, let's do it step by step. So from here, we have a 4AX is going to be equal to A squared plus 4H squared, which means that X is going to be equal to a over 4 plus h square over a. So this will be for the first part where we have successfully, now we have successfully find a formula for x in terms of h and a. Hence, I want to try to show that the value of h that will give a stationary value for v is the volume of the prism, satisfy that equation over there. Okay, we do need a volume, okay, something to represent the volume. So I can see from here, the volume is going to be area of the triangle multiplied by y. But what the question want me to show that satisfy the scenario where the volume is stationary is in terms of this equation here. This equation here is in terms of just h and a. Okay, so it shouldn't involve x and y. For x, it is fine because x I can express it in terms of a. So we do need to try to also find y in terms of a, because volume will be expressed in terms of x and y also, right? So we need to replace that y. So let me initiate that by making use of, let's say, this vertical part. Okay, this, if I were to look at this vertical part, then I know that this h plus y plus another h is going to be equal to 2a. So h plus y plus h is equal to 2a. This tells me that y is just simply going to be equal to 2a minus 2h. Okay, this is easy. So let's now try to quote the volume. Volume is going to be the area of the triangle, area of this triangle. So the area of this triangle is going to be half times base times height. It's going to be half times base. Base is going to be this. This is going to be a minus 2x, right? A minus this x minus this x. So here is going to be equal to a minus 2x times height. Height is equal to h multiplied by the, this is the area of the triangle, half times base times height. Then multiply, so we have this area here, then we are going to multiply by this, which is y. So this is the volume of the prism. And the next thing that I'm going to try to do is to express this entire expression here to be in terms of just simply a and h. So we are going to remove this x by making use of this. We are going to remove this y by making use of this. So this is going to be equal to half of a minus 2x. Oops, x I need to remove. So let me remove this x here. So it is going to be a minus 2x. X, I'm going to be replacing it by a over 4 plus h squared over a. Then I'm going to multiply by h. H, I'll let it be this y. I'm going to replace it. So it will be 2a minus 2h. So if I were to simplify this entire equation, expanding, there will be quite a lot of expanding to do here. So if you were to expand and simplify, okay, I'm going to let you guys try this yourself. It is just algebraic simplification. You will be getting this. You'll be getting a half a square h minus 1 over 2 ah square minus 2h to the power of 3 plus 2 over ah to the power of 4. So v is equal to this, and we are looking at the stationary value of v. We are going to make use of differentiation. We're going to find out what is dv dh. Okay, we're going to find out what is dv dh. Why are we doing dv dh? Because h is the variable. A is the dimension of the cardboard, which I'm going to be taking as the constant. So dv dh is going to be equal to 1 over 2a square, differentiating this, minus away half times 2 is going to be equal to just ah. Then minus away this will be 6h square. Then plus this is going to be 8 over ah to the power of 3. So with this, I am going to then let stationary value of v. I'm going to let dv dh here be equal to 0. So it is going to be half a square minus ah minus 6h square plus 8 over ah to the power of 3. This is equal to 0. I'm supposed to be proving what the question wants me to prove, where here is actually a negative 16. Okay, there's no a here, so I can remove a by multiplying this entire equation here by a. So I'll remove this a, and I'll need this become a negative 16. So I'll multiply this entire equation here by negative 2. So basically I'll multiply this entire equation here by negative 2a. So that I can get this to become a negative 16. So multiplying this by negative 2a, we will have a negative 16 h to the power of 3. Multiplying this by negative 2a will give us a positive 12ah square. Then multiplying this by negative 2a gives me a positive 2a square h. Multiplying this by negative 2a, this gives me a negative a to the power of 3, and it is equal to 0. So this shows for me what the question wants me to show, an equation that satisfies the scenario when v is experiencing its stationary value. So okay, we have done this, and in part 2, suppose that a is equal to 5, we are going to find the value of h that gives a stationary value. Basically, we are going to be solving this equation, explaining why there's only one answer. Okay, I've forgotten to shift this a little bit more, so now hopefully you guys can see this a little bit clearer. So we are going to make use of this. Okay, we are going to make use of this equation that is given. We are going to try to solve it. So let me erase this. I will still be needing this, so let me keep this here. Okay, so let me remove this also. Okay, so according to what the question says, next, when a is equal to 5. Okay, when a is equal to 5, we are going to try to solve for h by making use of this equation. We are going to be finding the value of h that cause v to be stationary. Okay, so this equation will become negative 16h cubed plus 12 times 5. A is going to be replaced by 5. Then h square plus 2a square times h minus a to the power of 3. This is equal to 0. And I will be getting this equation, negative 16h to the power of 3 plus 60h squared. This is going to be plus 50h minus 125. This is equal to 0. To solve this, let's just press it into our graphing calculator. So from my graphing calculator, I will be getting 3 values of h. One is negative 1.5451. This is obviously not applicable. Why? Because h, which is the height, it must be a positive number. So it's easy to reject. The other one is h is equal to 5 over 4. And one more, which is h is equal to 4.0451. Okay, I do find that it is harder for me to discuss, okay, like based on these two, which one is going to be rejected. So I did some, I did some analysis here and there. Oops, I'm supposed to be having this, okay, but anyway, I've already erased it. So, okay, if we were to need to refer, I'm going to just write it again, okay. So anyway, between these two, okay, we need to find a way to decide which one is going to be rejected. So, which will also help us to decide why there's only going to be just one single answer. And I think one good way for us to decide is to base on the geometry that is given to us, because one of them probably will be giving us a scenario where the geometry, if it is applied to the geometry, it will fail, it will physically fail. So if you have had, try a few times, which I had, the one that can actually show you, because what I did was I tried to verify whether, if h is equal to this value, either of these two values, whether it will satisfy this horizontal length, and then after that I try to verify whether it is going to satisfy this vertical length. I realized the vertical length is actually quite easy for us to verify. So let me make use of this length over here. Okay, so okay, actually it is not the vertical length, it is the horizontal length, but let me show you what I mean. So here, let's try when h is equal to, let me pick this value, 4.0451. Okay, but please take note that you will probably be looking at a few different ways to prove this. Okay, so I'm just writing the version of the answer that can help me to conclude. Okay, but in the actual exam, I'll probably have had scribbled a few more tests here and there before I find that this is the one. So when h is equal to 4.0451, if you can recall just now in the previous part, we have this. We have x to be equal to a over 4 plus h squared over a. Okay, we found this in part 1, which means that x is going to be equal to a, which is given to me as 5. So 5 over 4 plus 4.0451 squared over a, which is 5. And this gives me a 4.5226. What is wrong with this? Okay, you think about it. Now, the horizontal length here is a, which is 5. Let me write it down here. So the horizontal length or the width of the cut is equal to a, which is equal to 5. And now, this is going to be divided into x, and then this length, then x. But one of the x is already going to be equal to 4.5226 when h is equal to 4.0451, which means that if I were to go for a 2x, okay, assuming that I'm taking this length here plus this length here, 2x is going to be 2 times of 4.5226, which is going to be 9.0451, which means that 2x by itself is already going to be bigger than a, which is 5. 2x, okay, 2x is already going to be bigger than this length. This is physically impossible. That's why this is not applicable. That's why this is not applicable. And therefore, I will have only one value of h. And the value of h that will satisfy the geometry is going to be equal to 5 over 4. And hence, with this value, we're going to prove that it is also going to be the value that is going to cause v to be maximum. I'm going to use the second derivative test, and now is when I'm going to rewrite dv dh. So I should have just left it here. So anyway, just now we have found dv dh. dv dh was 1 over 2a squared minus ah minus 6h squared plus 8 over ah to the power of 3. So with this, we are going to try find, let's try find d squared v dh squared. So this is a constant, it is going to disappear. Here we are going to be left with a minus a minus 12h, then plus here is going to be 24 over a, h to the power of 2. A is equal to 5, according to what the question has given to me. So it is going to be minus 5, this is going to be minus 12h. This will be plus 24 over 5h squared. So let's try to check the positivity of d squared v dh squared when h is equal to 5 over 4. So d squared v over dh squared is going to be equal to negative 5, negative 12 times of 5 over 4 plus 24 over 5 of h, which is 5 over 4 square. If you were to press this into the calculator, you're going to get a negative 12.5. This is less than 0. Therefore, we have proven that the volume is going to be at its maximum, is a maximum. Okay, this is what the question wants me to prove. Yep, okay, done. Okay, we're going to go on to the next question. The next question is here. Question number 10. It is a differential equation question. So antibiotics are going to be used to treat bacterial infections. The rate at which the amount of antibiotics in a patient's body decays is proportional to the amount of antibiotics that is in a patient's body, and this is x at any time t. T is in hours. So based on this, we can actually start to write down the differential equation that is meant to capture the rate of change of x, the rate of change of the amount of antibiotics that is in a patient's body. According to what the question has described to me here, it is going to be experiencing this decay. So the rate of change of the amount of antibiotics that is in a patient's body is, the decay is described to me as proportional to the amount of antibiotics that is in the patient's body, it is going to be proportional to X, which is the antibiotics that is in the patient's body. We can add a little bit of influence to this equation because we know that there's a decay that is going on. A decay means that as time increases, X will decrease. Okay, as time increases, the amount of antibiotics will decrease. So dx dt is a decreasing value. So if I were to just add a negative and impose the fact that a is bigger than 0, this adds a bit more definition, okay, a little bit more depth into my differential equation, and I think this is probably a better version. Okay, so k is bigger than 0, I add a negative, it tells people that dx dt is less than 0. Next, part 2. Solve this differential equation, and we are supposed to find x in the form of x0 over pt, where p is going to be in its exact form, and we are supposed to determine this. Okay, I think let's try to first solve this differential equation. For what we have here, according to what we have discussed on Achevas TV, this is a variable separable kind of differential equation. So this is x here and this is x here. I'm going to shift this x over to the left hand side. 1 over x dx dt is equal to negative k, where k is a positive constant. Integrating both the left and the right hand side with respect to t, on the left hand side I'm going to be left with 1 over x dx, and on the right hand side the constant, I'm going to take care of the integration notation, so we'll be just simply integrating 1 with respect to t. On the left hand side, it is going to be ln of modulus of x is equal to negative kt plus an arbitrary constant. I'm going to just go for a to be the arbitrary constant, and we're going to try to make x a subject because that's what the question says. We are supposed to find x in the form of x0 over pt. So let's try to make x a subject first. This is going to be modulus of x is going to be e to the power of negative k plus a, which I can also rewrite this as e to the power of a, e to the power of negative kt. And removing the modulus, we will have x to be equal to plus or minus e to the power of a, e to the power of negative kt. And I'm going to just rewrite this plus or minus e to the power of a as another arbitrary constant. I'm going to call it b. So it's b e to the power of negative kt, where b here represents plus or minus e to the power of a. Let's try to solve for both b and k. So to solve for b, we are going to make use of the information that is given to us, which is here. Initially, the dose of antibiotics that is going to be administered is h, not h0. So it's not h, it is x naught or x0. So that means that when the time, initially, when time is equal to 0, the amount of antibiotics that is in the patient's body is x0. So that means b e to the power of 0 is x0. This is going to be 1. So b is going to be equal to x0 or h or x naught. Why am I always calling this as h? But it's probably influenced by the previous question. But anyway, this. So therefore, we know that this x here is x naught e to the power of negative kt. We still need to solve for k, and to solve for k, we are going to make use of this other information here. After 6 hours, t is in hours, so that is when t is equal to 6. So when t is equal to 6, after 6 hours, the amount of antibiotics in the patient's body is h again, is x naught over 1000. So x is equal to x naught over 1000, which is x0 e to the power of negative k times 6. This is h naught over 1000. H naught, come on. So anyway, x naught, they can be cancelled. I'm going to be left with this e to the power of negative k. This is equal to 1 over 1000, which means that e to the power of negative k, this is going to be 1 over 1000 to the power of 1 over 6. And in fact, this that is here, I can sort of like rewrite it, because 1000 is 10 to the power of 3. So this is to the power of 1 over 6. this is going to be the same as if I were to just rewrite this again to be like 1 over 10 to the power of 3. Then the whole thing to the power of 1 over 6. So we will now have a 1 over 10 to the power of 3 times 1 over 6, 1 over 2. So we actually have this as 1 over square root of 10. E to the power of minus k is 1 over square root of 10. So now we can rewrite x again. X is going to be equal to x naught, e to the power of minus kt, which is this x naught. This I'm going to break it up into e to the power of minus k to the power of t, right? Indices, this times this is going to give me this. So e to the power of minus k, we have proven that it is equal to this. So this is going to be x naught multiplied by 1 over square root of 10, this to the power of t. And we can even rewrite this into a form, it can be easier for me now to rewrite this into a form that is asked from us by the question, which is going to be this over square root of 10, then this to the power of t. So this will be in the form of the kind of expression that the question wants, where p, according to the question, p is going to be equal to this square root of 10. Okay, now we have this, and what's next? We want to hence find the time taken for the amount of antibiotics that is in the patient's body, which means that we want to find the time when x is going to reach 25% of the initial dose. So with this, okay, let me just continue here, okay? So with this that I have here, we are going to be looking at when x is 25% of the initial dose. So we are going to let the amount of antibiotics that is in the body be 25% of the initial dose, according to the question, is x naught. So this is this, which means that I'm going to just let this be equal to that, and I'm going to try to solve for t. So planting this in here, this is going to be x naught over square root of 10, then to the power of t. This is equal to 0.25 x naught. So x naught can be cancelled. We have a 1 over square root of 10 to the power of t is equal to this, which is actually just 1 over 4, right? So if I were to just cross multiply, we have a square root of 10 to the power of t. This is going to be equal to 4. Ln both sides gives me a t ln square root of 10 is equal to ln 4. So t is going to be equal to ln 4 divided by ln square root of 10. And pressing this into the calculator gives me t as 1.20 hours. Okay, this is part 2. Let's move on to part 3. In part 3, as the amount of antibiotics that is in a patient's body decays with time, pharmacies recommends administering the antibiotics every t hours with a dosage that is of the same amount that was administered initially, x0, x0, for an extended period of time. So part 3, we want to state the amount of antibiotics that is in the patient's body immediately after the second dose. The first dose is going to be this. Okay, this will be the initial dose. This is the first dose. Then the second dose will be another x0 that is going to be added to the patient's body. So just now we have found in part 2 that x is equal to what? X is equal to x0 over square root of 10, then this to the power of t, which means that now when t is equal to t, okay, because according to the question, every t hours, an additional dosage of x0 is going to be added to the patient's body. So by the time when you first reach the t hours, x will be x0 over square root of 10 t. And at this point, a second dose is going to be added, and the second dose is x0. So this will be the amount of antibiotics that is going to be in the patient's body immediately after the second dose. Okay, I'm answering this. And then the question says, hence. Hence, show that the amount of antibiotics that is in a patient's body at time t after the second dose, after this second dose, but before the third dose is equal to that expression. I find myself like pausing for a while more than as I try to analyze the other question, to think about what exactly is happening here, because something didn't change, which is going to be how the antibiotics will be decaying in the patient's body. And if that didn't change, that means this relationship will not change. Even after the second dose of this X0, even after the third dose, as long as it is the same patient's body, the decay shouldn't change. If the decay doesn't change, that means K here will remain the same. Okay, just now we have tried solving for this differential equation, and we have gotten this, right? We have gotten x is equal to b e to the power of minus k. Then we have gotten this. We have gotten minus kt. Okay, just now we have gotten this from part 1, and that was before we managed to solve for b and k. So now it seems like we have another decaying that is happening. But if I were to just treat this as a totally new decaying, I will not be able to show what the question wants me to show, as in like what that is happening here. So I need to rely on my previous experience in solving this particular scenario, which is like what I was just saying, because the decay doesn't change. So if you think about it, things has changed because B would have changed, because this is as if it is a new round of decay that is happening. And B, we obtained it just now based on the fact that time was equal to 0, if you can remember. Okay, that was how we solved for B. So B changed, but K is not changing. Okay, like what I was saying, the pattern of decay doesn't change, which means that in this second setup here, after the second dose, I'll still be working on the same thing, which is e to the power of minus k is equal to, what was it that we found just now? We found this to be equal to e to the power of minus k. We found this to be equal to 1 over square root of 10. Okay, so we are not going to be changing this, which means that what I'm going to do is when t is equal to t, okay, I know that it is supposed to be this amount that is going to be in the patient's body, but bringing in the actual decay that is continuously happening, I'm going to replace this x here by this x, okay, as if we have still unknowns to solve for, but this time b is going to be the only unknown. We probably should use another arbitrary constant instead of b, okay, but just to make sure that just for us, you have to communicate about the fact that I'm relating this to the past experience, I'm going to use the same b still. In exam, I think preferably we should try to change it to c or something. So see, this e to the power of minus k, I let it remain. So it's going to be this 1 over square root of 10, then to the power of t. Okay, let me just very, very quickly explain this one more time. Why did I let this remain? It is because, this is when t is equal to t, so I got to write this as t. But I let this remain, e to the power of minus k remain as the same as what I've solved previously, because the decay shouldn't have changed, even after the second dose. Okay, and the only unknown that is in the way the whole behavior was decaying is k, not b. So k is the one that remained constant, b will change. So I'm going to solve for a new b while maintaining the same k. This is equal to x0 over square root of 10 to the power of t plus x0. So we have this case here is like a b over square root of 10, then t, this is equal to x0 over square root of 10, then t, this is plus, adding to x0. So b here is going to be multiplying this across. We will have x0 plus x0, then square root of 10 to the power of t. So this is going to be the new b, which means that if this were to be the format of the solved differential equation, that means x is going to be equal to the new b, which is going to be this x0 plus x0 square root of 10 to the power of t. This is the new b. Then multiply by e to the power of minus k, which is this. So multiply by 1 over square root of 10, then to the power of the variable t. So this is going to be the solved differential equation, which is going to be the amount of antibiotics that is in the patient's body after the second dose and before the third dose. I'm trying to answer the question here. Okay, after the second dose and before the third dose. Let's try to manipulate this, and we should be able to get what the question wants us to show, which will require us to factorize out this x0. So I'm going to factorize out x0, which will then leave me with 1 plus square root of 10 t. And if you were to look at what the question wants you to show, I'll probably not keep the square root of 10. I'll change it to 10 to the power of half. So 10 to the power of half to the power of t is going to be equal to 10 to the power of half t. Then this I'm also going to be changing. I'm going to be changing this to 10 to the power of minus half, right? Then to the power of t, so 10 to the power of minus half t. Let's bring this in. Then this will be equal to x0. Bring this in, we will have a 10 to the power of negative half t plus 10 to the power of half t, then 10 to the power of negative half t. I think we are getting it. This is going to be x0, and I am going to write down this first because I'm trying to show what the question wants me to show, and combining these two together, we will have a 10 to the power of half t minus half t, which is going to be half of t minus t. Okay, I get one part of what the question wants me to show already. It is this here. Okay, in case it's not clear, so I have this. Then after that, this term here, okay, which is going to be plus 10 to the power of negative t over 2. So this is what the question requires me to show. Okay, this is question number 10. Let's look at question number 11. So 11 part 1, we are supposed to sketch this graph, and then we are going to solve an inequality. So part 1 is a graph and inequality question. Then the next few parts are, okay, there's a function there, so I guess the next few parts is going to be a function related question. Personally, when I try to draw this graph, when I try to sketch this graph, I find that there's not a big issue pressing this into the calculator, but I will probably miss out details. Okay, I mean, you guys can try it, see whether your graph is going to be similar to mine, or just have a feel of what kind of details you're going to be missing. And I'm saying this because I've already pressed it directly into my calculator, and I realized that my calculator makes the details so small that it is most likely going to be, I mean, I will most likely miss it if I were to be rushing through this question in the exam. So I'm going to try to approach this in a slightly different way, which is to do this sketching, right, based on transformation. Okay, I think that actually really will prevent me from missing out one detail that is going to be very, very subtly displayed on my calculator, that's such that I may even miss it. So what I'm going to try do is, I'm going to try to sketch this graph first, which is the graph of y is equal to half plus 1 over x minus 3. Okay, as if this entire expression here in the modulus is just x. So I'm going to sketch this graph first. This is easy to sketch. For this graph that is here, I can already predict the asymptotes. It has a horizontal asymptote of y is equal to half. So let me sketch it. Y is equal to half. And it has a vertical asymptote of x is equal to 3. So it is going to be something that is like this. This is x is equal to 3. We have this here. And we have another one that is here, like this. Okay, and for the y-intercept here, the y-intercept here is at 0 and 1 over 6. And the x-intercept here is at 1, 0. So this is this graph. Then what I'm going to do is I'm going to do transformation. I'm going to first transform this by replacing x by modulus of x. So which will give me half, then plus 1 over modulus of x minus 3. And this will give me a graph that looks like this. Here, This is the x-axis. I'm going to keep this vertical asymptote here. So here I will continue to have x is equal to 3. I'm going to keep this horizontal asymptote, which is y is equal to 1 over 2. So this part of the graph will remain the same. And this part of the graph will also be remaining the same. So we have this. Okay, where this point here is 1, 0. And this point here is 0, 1 over 6. And because of the modulus, we are going to be reflecting this over to the other side. So that will give me a vertical asymptote here, and this will be x is equal to minus 3. And then this part is going to be reflected. So I will have something that is like this, where this point here is going to be the reflected point. So it's going to be at minus 1 and 0. Okay, and please take note that this is going to be a sharp point, right? Because it is going to be reflected. At this particular point here, the tangent is going to be at an angle, which means that when I reflect it, if the tangent is going to be at an angle, the reflected tangent is also going to be at an angle. So this point here, it has to be a sharp point. It has to be visibly a sharp point. Then after that, it is going to be this portion being reflected. So I will have this. Okay, and finally, from here, I'm going to be replacing x. I'm going to do another transformation by replacing x with x minus 2, then minus 3. So the entire graph is going to be translated by 2 units in the positive x direction. That will lead me to my actual graph, which I'm going to now sketch it here. This. And we have a horizontal axis, the x-axis, let's say here, the x-axis, the y-axis. The horizontal asymptote remain the same even after the transformation. So y is equal to half is going to continue to be here. Let me do a sketch of it. Okay, so here we have y is equal to 1 over 2. The 2 vertical asymptotes are going to be translated by 2 units in a positive x direction. So x is equal to minus 3 will become x is equal to minus 1. We have a vertical asymptote here. Okay, this is x is equal to minus 1. And x is equal to positive 3 will become x is equal to positive 5. So we have another vertical asymptote here. This is x is equal to 5. So I'm going to sketch this part of the graph, which is going to be here. The entire graph is going to be translated by 2 units in the positive x direction. So the other portion is going to be here. And I'll make sure that my graph tends towards the asymptotes. And the last part is going to be this, with a sharp point here, which I'm going to try to display as prominently as possible. So it is going to be here. Here. Cutting. Yep. I have my sharp point. Then coming back down. Here. All the way. Okay, and this point here is at 1, 0. It is a transformation of this point, plus 2, so it will become 1. And this point here, goodness, it is a very, very cramped graph. This point here is 0 minus 1 over 2. For this, I'll probably press the original graph or letting x be equal to 0 in the equation that is given to me to find the corresponding y coordinate. As for this maximum possible point here, I can also try to press it into the calculator. This is at 2 and 1 over 6, or simply us transforming this point here. Okay, this point here, which is 0, oops, I forgot a bracket. So 0, 1 over 6 will become 2 and 1 over 6. And we have another point here. This point here will be 3, 0. It is a transformed point from this 1, 0. So this, it may seem like very unnecessary, right? Like, why did I do a transformation? For those of you who actually try to press this graph, let me just label this graph. Y is equal to 1 over 2 plus 1 over modulus of x minus 2 modulus minus 3. For those of you who have actually pressed this graph, directly into your graphing calculator to sketch, you probably will not be able to spot this point being a sharp point, because on the calculator, it will most likely look like a nice curvy maximum point, especially when this point actually has a very, very small y coordinate, which means that it is very, very close to the x-axis. And if everything is very much crammed together, okay, this sharp point will appear almost like curve. That was what I have experienced when I was trying to press this into the calculator, but I know that with a modulus here, there should be some sharp point that is going on. Okay, that is why I decided that in order for me to find that sharp point, I would either have to zoom and zoom and zoom, which in an exam, I may not even know where exactly I'm supposed to be zooming, or I can do a transformation, which in the end turns out to be fast and accurate. But this question is really very tricky, because what I need to do next is to draw one more graph, because in order for me to solve that inequality, this inequality here, in order for me to solve for 1 over 2 plus 1 over modulus of x minus 2 minus 3 to be bigger or equal to 1 over x minus 1 over 3, I need to draw another graph. So I need to draw this other graph, the graph of y, the graph of this. Okay, I need to draw the graph of y is equal to 1 over x. 1 over x minus 1 over 3. This is an easy graph to sketch. The problem is I will need to be sketching this here. Okay, and this I don't really have a good way for us to watch out for all the details. So I'm going to just sketch it in, and hopefully you will be able to capture enough of the details in order for you to answer this part of the question correctly. So let me draw this graph. This graph has a vertical asymptote of x is equal to 0. I'm going to indicate it in. So here, x is equal to 0. And this graph has a horizontal asymptote of x is equal to minus 1 over 3. Minus 1 over 3 should be above minus 1 over 2. So I'm going to sketch a horizontal asymptote somewhere here, okay, above this y-intercept. So let's say it is this. Okay, and this that is here is y is equal to negative 1 over 3. I think this portion here is fine. So if I were to just follow what I have on the calculator, sketching this part is not too bad. It is going to be like this. And the place where it intersects has a x coordinate of minus 3 over 5. The y coordinate is minus 2. The problem is actually this portion. Okay, if you were to sketch both the graphs on your calculator, which means that ultimately, even if you were to be doing your transformation, it would still probably be necessary for you to sketch this into your calculator. But at least doing a transformation helps me to capture this point here. So if you were to sketch this in a calculator, you'll realize that, yes, it is going to be coming down from here because there's a vertical asymptote of x is equal to 0, but it will be passing through this point here, the maximum possible point, to 1 over 6. Then you'll be passing through this 3, 0 below it. So let me just exaggerate it a little bit, okay? You will pass through it below. Then you will tend to the horizontal asymptote. Y is equal to minus 1 over 3. Okay, it is again going to be a very tiny looking part of the graph. So you will need to be zooming, or by feel, you need to check how they are going to be intersecting. And when you check, you will also realize that is going to be happening. Okay, so it's going to be intersecting at this point here. It's going to be intersecting at this point here. So this red colored one is my graph of y is equal to 1 over x minus 1 over 3. And there's still one more challenge, which is to actually read this graph in order for us to answer this inequality. So what I'm going to do to just help myself read this graph properly is to just try to consolidate this into one single number to watch out for. And that number, or this on my graph, is going to be represented by, I'm going to use black color, y, let's say y1, okay? Which means that this, I'm going to call this as y1. Okay, it is just for me to visually distinguish this y from this y, which represent the red colored graph. I'm going to call this y2. So this here, I'm going to look at it as y2. So what I'm going to try to look out for is the range of values of x such that y1 is bigger or equal to y2, such that y1 is bigger or equal to y2. So I want to make sure that if I were to draw a vertical line, or if I were to imagine a vertical line, the black colored graph must be above the red colored graph, because y1 must be bigger or equal to y2. Let's see when that will happen. Okay, obviously it is happening to the left hand side of x is equal to -1, right? Because the black colored one is above the red colored one. So one of the answers will be x is less than -1, strictly less than -1, because we have a vertical asymptote here. Is there any other portions? Yes. Another portion is between here and here, where the black colored graph is above the red colored graph. So here is when x is equal to -3/5, because it can be equal to, so the other region is such that x is going to be bigger or equal to this, to the right hand side of this, bigger or equal to -3/5, but it should be strictly less than 0. Not equal to 0, not equal to 0, it is strictly less than 0, because for the red color graph, it will never actually touch 0. So at 0, it is impossible for y1 to be bigger than y2, because there is no y2. So it must be strictly less than 0. There is still more regions. We are looking for regions where the black color graph is above the red color graph, which is this portion here, this small little tiny portion here. And that is when x is bigger or equal to 2, the x coordinate of this point, and less than or equal to 3. Is there any more regions where the black color graph is above the red color graph? There's still one last region, which is going to be here, right? This is when the black color is bigger than the red color. So this is going to be when x is going to be compared to 5, and this time it is strictly bigger than 5. It cannot be equal to 5, because when x is equal to 5, yes, there is a red colored y2, but there is no black colored y1. y1 is undefined. It is a vertical asymptote. So you will never be able to find a y1 that is bigger or equal to y2 and x is equal to 5. So I'm keeping that out from my answers. This will be for my part 1. And I think it is a very, very tedious and tricky graph to sketch, and a very, very tedious and tricky inequality to try to solve. Actually, the same is going to go for the next few parts of the question. Let's try to experience it together. Okay, so for the next part, we are looking at two functions, f and g. F is based on an expression that is the same as this one that we have just sketched. So I'm going to just resketch another version, okay, just to be customized for this function. And the good thing is, we are only looking at the region that x is between -1 and 1. -1 and 1, okay, which is here, -1 and 1. Okay, so this is good. Let me just resketch this. So it is going to be this here. Okay, I think I just need a small little axis to draw this graph of y is equal to fx this time. So we are going to retain this vertical asymptote, x is equal to -1. X is equal to -1. And we'll be sketching all the way until the place where x is equal to 1. So it is going to be from here, and then it will be until here. According to the question, we are looking at x for fx. Okay, we are looking at x to be strictly bigger than -1, obviously, because x cannot be equal to -1. It's a vertical asymptote. And then strictly less than 1. So we have a hollow dot here. This point here is at 1, 0. And this is this point. So this is going to be at 0 and -1/2. So we have this as y is equal to fx. Okay, now I can erase this. This is like really distracting. It's a confusing graph. Okay, so we have this, and we have gx. Okay, I'm not going to care about gx for now. Okay, we're going to look at it maybe in part which one is it? Part 3. Okay, part 2 only involve f, so I'm going to look at this. So for part 2, we are going to try to find the expression for f inverse, and then we are also going to try to state its domain. Okay, so we are going to let y be equal to fx, which means that y is going to be equal to half plus 1 over modulus of x minus 2 minus 3, where x is supposed to be between minus 1 and 1. Okay, so this is fx. There's something that we should try to do, like either now or maybe even later, which is to try to manage this modulus of x. Because if I were to try to make x the subject, okay, later on we are going to be having this plus or minus when I try to remove the modulus. And the problem is, it is going to be, I mean, you guys can try, it is going to be harder to decide with that plus or minus, which one should I keep. But the thing is, now when it is still being contained in this particular modulus of x minus 2, it is actually easier to make that decision now. Because what is the modulus function? Let's just do a quick recap, okay? If we have a modulus of a function, let's say we keep it simple, okay? We have a modulus of an expression, x, let's say. This is defined as a piecewise function. It is going to be x when whatever that is inside is positive or 0. It is going to be minus of it when whatever that is inside is less than 0. This is a piecewise function. This is a modulus function. So, which means that if I were to look at what that is given to me here, a modulus of x minus 2, we would know whether it is going to be a plus or minus if we can decide whether x minus 2 itself, without the modulus, whether x minus 2 itself is a positive or negative number. And we can decide based on here. X is between minus 1 and 1, which means that x minus 2, if I were to minus 2 throughout, is going to be 1 minus 2 is going to be minus 1, but this minus 2 is going to be minus 3. So x minus 2 is a negative number. If it is a negative number, we're going to add a negative to it through the modulus function. So this y is going to be equal to 1 over 2 plus 1 over, this is negative of x minus 2 minus 3. And this is because we have decided that x minus 2, this expression that is inside, is actually a negative number. Okay, so based on this that we have, let's continue and make x a subject. So I'm going to bring the half over to the other side. We have a y minus 1 over 2. This is equal to 1 over minus x. Then we have a minus x minus 1. Okay, I think I'm going to just multiply negative over to the other side, okay? So we have a 1 over x plus 1 is going to be equal to half minus y, which is 1 minus 2y over 2, which means that x plus 1 here is going to be equal to 2 over 1 minus 2y. So x here is 2 over 1 minus 2y minus 1. So this gives us the expression for f inverse. It is equal to 2 over 1 minus 2x minus 1. And we are supposed to find the domain, right? We are supposed to find the domain of f inverse, which is the same as the range of f. We have a graph to refer to. Thank goodness for the first part of the question. We have put in that effort. Now we are reaping that effort because it is going to be an easier graph for us to look at now. From here, what is the range? It is all the values of y. And all the values of y states that it is going to be from minus infinity all the way until 0, y here, until 0. But it is not inclusive of 0, so this gives us the domain of f inverse. Let's take a look at the next one, part 3. And now in part 3, we are going to try to find the exact range of g, okay? And g is definitely not one function that I want to see in the exam because, first of all, we have this sine pi x over c. This is a very heavy burden to carry during the exam, and the domain doesn't look friendly at all. It is from 5c over 3 all the way until 14c over 5, where this c is a positive real number, okay, according to what the question says. So we are supposed to find the exact range of c, and I think what I should try do first, right, is to sketch the graph of gx. So we are supposed to find the range of g, not c. We are supposed to find the exact range of the function g. Let's draw the graph. It's a sine graph. It's a sine graph that has undergone a transformation. What is the transformation? It is from sine x, we replace x by pi over c x, which means that the transformation requires the original graph to be scaled by a factor of c over pi, parallel to the x-axis. It's going to be scaled by c over 5, parallel to the x-axis, which means that on the original graph, when we have a period of 2 pi, now we are going to be having a period of 2 pi multiplied by c over pi, which is going to be equal to 2c. The new period is 2c. If I can just sketch the graph as a general sine graph first, I think it is actually going to be easier. Knowing that the input into the graph is always going to be positive, I'm going to start from 0. So a sine graph will typically look like this, right? And so on. Okay? The maximum possible value here is going to be at 1. The minimum possible value is going to be minus 1. This doesn't change. The amplitude is going to be still 1. So the maximum minimum is still going to be plus or minus 1. What that is going to be changed is everything that is on the x-axis. 2 pi, the original 2 pi, one full period, is going to be changed to 2c, which means that here is going to be c. So here is going to be equal to 3c. So here is going to be equal to 4c. If I were to just add in a bit more detail, then here, this is going to be this in between this, right? So 2c plus 3c divided by 2 is going to be 5c over 2. And the reason why I'm quoting all this, I better quote this also. So it's going to be this plus this divided by 2. So this is going to be 3c over 2. The reason why I'm quoting this is because I'm trying to find where exactly I can position this number and this number. 5c over 2. 5c over 2 is between this and 2c. So 5c over 2 is, let's say, somewhere here. Okay, this is where I see my 5c over 3. It's 5c over 3. So if I were to just extend down, it is going to be this, which means that the graph starts from here. The graph of G starts from here. Then it will go all the way until 14c over 5. And 14c over 5 is between 5c over 2 and 3c. It is going to be somewhere, let's say, here. Okay, so this is where I see a 14c over 5. So x is going to be between here and here, which means that my graph of G is going to be this portion here, from here all the way until here. So the maximum it will go is 1. This is fine. And the minimum, I need to find this number here. Okay, because the range is going to be from here all the way until 1. This is fine because this is not going to be affecting my range. So in order for me to find this, I'm going to substitute 5c over 3 into this. So let's try to find G of 5c over 3. This is going to be equal to sine of pi x. X is going to be this 5/3 over c. So this multiplied by 5c over 3. Okay, c and c can be cancelled. We are going to be looking at a sine of 5 pi over 3. Sine of 5 pi over 3. We can actually try to reimagine this. What is sine of 5 pi over 3? Sine of 5 pi over 3, if I were to minus 2 pi to this, then this is the same as sine of minus 2 pi over 3. So we have a special angle. It is in the third quadrant. So this is going to be negative square root of 3 over 2. negative square root of 3 over 2. Let me just check my answer here. Did I get it correct? Yep, this is negative square root of 3 over 2. So this number here is negative square root of 3 over 2. This provides for me the range, which is what the question wants. So therefore, the range of G is going to be from here all the way until 1. So the range of G is going to be inclusive of this negative square root of 3 over 2 all the way until 1, which is also inclusive. So we have this, the range of G. Next, part 4, and we are looking at H. H is like G. Let's try part 4. Let me write it down here. So H is sort of like G, where the domain is going to be changed. It's going to be changed from 5 over 3c to 3c over 2. It is going to be strictly bigger than, and it is going to be strictly less than another one here, which is going to be this 5c over 2. Okay, let me erase this. And we're supposed to find FH inverse. Let me try to write it down. FH inverse of minus half. We are supposed to find this in terms of C. Okay, find this in terms of C. So in order for me to do this, I think what I'm going to try to do is to let this be equal to K, because I definitely don't want to find the expression for FH inverse. Okay, that is very, very tedious, but by letting this be equal to K, my intention is to solve for K. But what I can do is I can just apply FH on both sides. That will help me to remove this inverse, which will then give me this is equal to FH K. It is almost as if I were to just apply it as if it is a rule, it is almost as if bring this inverse over to the other side. So we have this, and for FH, okay, I mean, it is complicated, but it's not as complicated as me finding the inverse, right? So for FH X, it is going to be putting H into F. So that will be 1 over 2 plus 1 over modulus of sine pi x over c minus 2, then minus 3. Which means that we have a minus half. This is going to be equal to this, which is half, plus 1 over modulus of sine pi k over c, because x is going to be replaced by k, then minus 2 modulus minus 3. Let's try to solve for k over here. So we will have a 1 over this modulus of sine pi k over c minus 2 minus 3. This is equal to minus 1. Cross multiplying negative, I can also bring it over to the left hand side. Then modulus of sine pi k over c minus 2 modulus minus 3. This is equal to minus 1, which means that modulus of sine pi k over c minus 2 modulus of minus 3. This is minus 3. I'm going to be bringing it over to the other side. So this is equal to 2. And now I'm going to break up the modulus, okay, to plus and minus algebraically. I'm going to write my two versions here and let's say here. So removing the modulus gives me two versions to this equation. Minus 2, this is equal to 2, this is one equation. The other one will be sine pi k over c. This is equal to, minus 2. This is equal to minus 2. Okay, I'm removing the modulus and replacing it by plus or minus, so I get a plus or minus 2. As for this over here, we will be getting something that is going to be rejected because minus 2 bring it over to the other side gives me 4. It is impossible for me to find a value of k such that when I input into this gives me a sign that is equal to 4. Sign is going to be between plus and minus 1, so it is impossible. So this is going to be rejected. As for this, we can continue. This we have a pi k over c. This is going to be equal to 0, which means that pi k over c is going to be equal to multiple values. All the values that will cause sign to be 0 will be numbers like 0, of course, pi, then 2 pi, 3 pi, and so on. We need to find a way to decide which are the values that is going to be helping us to get the answers. Okay, and to do that, right, what we need to do is to look at the composite function. Okay, if I were to look at this composite function here, okay, it's the same as looking at the composite function here. What do you think is the domain of this composite function? Why am I talking about the domain? Because it spells out what can go into fh. It spells out the range of values of x. It tells me what is the range of values of k, such that it can go into the composite function fh. And the domain of the composite function is the same as the domain of the first function, which is h, which means that this k or this x here, let's go for k, okay? That means this k has to be the same as the domain of h, which is going to be between 3c over 2 and 5c over 2. So if I were to try to solve for the values of k, I will only be accepting values of k that is going to be between 3c over 2 and 5c over 2. So let's try. So k here is going to be values such as 0. Multiplying this c over pi over to the other side, it is going to be giving me pi can be cancelled. This is going to be giving me c. This is giving me 2c. This is going to be giving me 3c, and so on. Of all these numbers, there's only going to be one number that is going to be between 3c over 2 and 5c over 2, which is 2c. So I'm going to be rejecting all and keeping just 2c. This will help me to solve for the value of k. And what is k? K is this. So therefore, since we have already solved for k, therefore we know fh inverse of minus 1 over 2 is equal to k. This is equal to 2c. Okay, finally, we're going to be moving on to our last question. It is a vectors question. So for this question number 12, we have two lines. Let me write down the equation of the two lines. So L1, we are given it as R is going to be equal to 10, 8 plus lambda of 1, 14 h. And L2 is given to me as R is equal to S negative 10, 12 plus mu of 2, 2, negative 5. We are also given that L1 and L2 are skew lines and they are also perpendicular. We want to find the possible values of h and s. H is this. We're going to find h. We're going to find possible values of h and s. So they are perpendicular. So if they are perpendicular, that means the direction that they are parallel to, they must be right angled to each other. So 114h dot 2, negative 5. This must be equal to 0. We have a 2 plus 28 minus 5h is equal to 0. This helps me to solve for h. h is equal to 6. Let me just replace this over here. We have already solved for this. So we now know that this is 6. And we have one more unknown to solve for, which is s over here. And I'm going to make use of the fact that they are skew lines. Skew lines are non-intersecting lines. So if I were to try to solve the intersection between L1 and L2, I shouldn't get any consistent results, right? So let's try to make use of this fact. So let's say we are really trying to solve for the intersection between the two lines. That would be when I let this be equal to this. So I will let this, which is 10 plus lambda, 8 plus 14 lambda, 8 plus 6 lambda. I'm going to let this be equal to this, which is s plus 2 mu, then negative 10 plus 2 mu, and 12 minus 5 mu. Based on the first row, we have a 10 plus lambda is equal to s plus 2 mu. I'm going to leave this row as it is first, because there's an unknown here, which is s, which we are trying to solve for. I'm going to work on the other two, which is this 8 plus 14 lambda is negative 10 plus 2 mu. If you were to bring everything, all the variables to one side and simplify them, you are going to be getting a 7 lambda minus mu is equal to negative 9. And for the last row here, it is a 8 plus 6 lambda is equal to 12 minus 5 mu, which can also be rewritten as 6 lambda plus 5 mu is equal to 4. And I'm going to solve these two equations first, since we have two equations and two unknowns, lambda and mu. Pressing this into the calculator gives me lambda to be equal to minus 1 and mu to be equal to 2. But that is if I were to just be assuming that the y and the z coordinates are the same, but it shouldn't be, it shouldn't satisfy whatever that is happening to the x coordinate, because there's not supposed to be an intersection, which means that these two values, although it may seem to be giving me a solution for these two equations here, but these two values shouldn't satisfy this. Okay, in order for these two lines to be skew lines, we shouldn't find a consistent value of lambda and mu that satisfy all the three equations. So what I'm going to do is, I'm going to substitute these two into here. On the left hand side, we will have a 10 plus lambda, which is minus 1. Then this is s plus 2 mu, which is going to be 2. But this shouldn't be happening. Okay, that is why I'm letting this not to be equal to each other, because we are working on skew lines. So this will help me to work out the value for s. S is not going to be equal to 5, which means that what is the values of 5 for s? S is just basically all real numbers except 5. So s is going to be belonging to all real numbers other than 5. I'm going to use a notation that is like this, or you can just say s is all real numbers except 5, except s is equal to 5 or something like that. Okay. Next, let's move on to B, which we have this diagram over here. Okay, and based on this diagram, I'm going to just redraw it from the like the side view. So for this roof that the question is mentioning, for this roof, I'm going to draw it this way. Okay, so we have something that is like this to represent the roof, and according to the question, this roof can be modeled by a plane. The equation is this. So let me just indicate it here. This is like r dot 608. This is equal to 25. And for this spherical ball that is here, this advertisement ball that is here, I am going to draw it here. So let's say this is a spherical ball. Okay, according to the question, this spherical ball has a radius of 1 unit. And the origin starts from the center of the spherical ball. So here is the origin. I'm going to put O. This is like O, O, O. And according to what the question says, OA starts at this point, negative 2.505. So let's say from here to a point A, I'm not sure where it is. Let's say it is here. Okay, so let's say this is point A. Let me indicate the coordinates for us. Negative 2.5, 0, and 5. And as for point B, it is mentioned to me that point B is such that it is connecting to the roof, such that this chord is going to be the shortest possible from the center of the ball to the roof, which means that point B, if it is the shortest possible, it is going to be something like this. This is going to be 90 degrees, shortest possible. So in part 1, we are supposed to find the coordinates of point B and hence find the shortest possible distance from the surface of the advertisement to the surface of the advertisement ball to here. Okay, where this length here, let's not forget, okay, this length here is 1 unit. So what I'm going to do is to find the foot of the perpendicular from the origin to this plane. Okay, it is the foot of the perpendicular from the origin to the plane. So what I'm going to do is, I'm going to form for myself in part 1, it is a foot of the perpendicular from a point to a plane question. I'm going to form for myself a line that passes through O and B. This will be R is equal to, I'm going to write down the position vector of a point that is on this line, and obviously I'm going to use the origin. It's the easiest point to make use of. then plus lambda of a direction that is parallel to OB. Do we have a direction that is parallel to OB? Yes, we do, because the normal to the plane should be parallel to OB. So I'm going to make use of this 608. So this is equal to lambda of 608. This is the equation of the line that passes through OB, which means that at a point B, it is where the intersection between this line and this plane appear. Okay, this is the intersection between these two geometry. So I'm going to substitute this R into this R. I'm solving simultaneous equation as if this is equation number 1, equation number 2. I'm substituting equation number 2 into equation number 1 to solve for the intersection between the two geometries. So this R, I'm going to be replacing it by lambda 608. So we have this dot 608 is equal to 25. So it is going to be lambda of 6 times 6 plus 0 times 0 plus 8 times 8. This is equal to 25. Lambda is going to be, this is 100. So it's going to be 25 over 100. Lambda is going to be equal to 1 over 4. Therefore, we know that OB is going to be equal to 1 over 4 of 608. OB is equal to 3 over 202. And we are supposed to give the coordinates. So this is in position vector form. The coordinates form will be 3 over 2, 0, 2. And we also want to find the shortest possible distance between the surface of the ball here to here. And this is 1 unit, so the required distance is going to be, which is this distance here, is going to be modulus of OB minus away 1. Okay, minus away the radius of the ball. So OB is this, it is going to be square root of 3 over 2 square plus 0 square plus 2 square minus 1. This, if you were to press into your calculator, this is 5 over 2 minus 1. We have our answer here as 3 over 2. Next, part 2. To further secure the suspended advertisement ball, a third hanging chord OD is added to this, such that OD is a reflection of the chord OA in the chord OB. I think this is actually pretty simple because OD is supposed to be here. A reflection of OA about OB is giving me a D that is somewhere here. Okay, and we are supposed to find the equation of the line that represents this OD. Because it is a reflection, we are looking at these two distances to be the same, which means that proportion-wise, it is going to be 1:1. And we have the position vector of A, we have the position vector of B. We can make use of the ratio theorem to find the position vector of D. This is not a problem. So let's do that. So for part 2, OB using ratio theorem is going to be 1 time of OA plus 1 time of OD divided by 1 plus 1, which means that OD is going to be equal to 2 times of OB minus OA. It's going to be 2 times of OB, which is 3 over 2, 0, 2, minus away OA, which is going to be negative 2.505. This gives me OD as 11 over 2, 0, minus 1, which if I were to factorize out half, it is 11, 0, minus 2. And we are supposed to quote the equation of a line that passes through OD. So that line that passes through OD will be a line that passes through the origin 0, 0, 0, plus I'm going to go for mu of a direction that is parallel to OD. I will just make use of this 11, 0, minus 2. So the equation is going to be just simply mu 11, 0, minus 2. Next, we have this LED, what is this? This LED, this LED light panel that is going to be squarish. Okay, let me just erase this first. Okay, let me write down the information that we have so far. Let me shift this a little bit. So the equation of the plane, this plane here, is R dot what is this that was given to me? This is r dot 608. This is equal to 25. And the information that I found so far will be the coordinates of point B. So the coordinates of point B, let me erase this too. The coordinates of point B, we have found it to be equal to 3 over 2, 0, 2. And we have also found the coordinates of point D. Let me just write it down too. So this is 11 over 2, 0, minus 1. Now we have this LED light panel that is going to be installed between the advertisement ball and the roof. Okay, it's going to be installed somewhere here. This panel is going to be of a distance of 0.8 from the roof. So we have this panel here that is lying here, where the distance, this distance here, is given to us as 0.8. So this is the LED panel. I'm going to call it pi LED, okay? So pi LED. So we're supposed to find the Cartesian equation of this plane. With this plane that comprises of this LED light panel. So we have the distance between two parallel planes. I'm going to make use of the equation that is on that I've made use of on the Achevas TV about the distance between two parallel planes. So first of all, I will need, in order for me to make use of that equation, okay, I will need the format of this pi LED. So for this pi LED, it is parallel to this roof, which means that they can share the same normal vector, 608. But what I'm missing is this portion for this pi LED. I'm going to just simply call it P for now. Then making use of the equation or the formula for the distance between two planes, which is going to be modulus of P over, for this, P over modulus of 608 minus away 25 over modulus of 608. This is going to be equal to this distance here, 0.8. So with this, I should be able to solve for P. So let's try. It is going to be modulus of P over square root of 6 square plus 0 square plus 8 square. This is going to be equal to square root of 100. So this is going to be 10 minus 25 over this will also be 10. This is equal to 0.8, which means that modulus of this is going to be equal to 10 multiplying across to the other side. This is going to be equal to 8. So P minus 25, this is going to be equal to minus 8, or P minus 25, this is going to be equal to positive 8. This tells me that P is going to be either 17 or P is going to be equal to 33. We need to reject one of them. And the reason why we have 2 is because for a plane to be of a distance 0.8 away from the roof, it can be either here or at the other side. Here or at the other side, correct? But according to what the question says, it should be at the side that it is between the plane and the advertisement ball, which means that it should be the one that is nearer to the origin instead of the one that is further away from the origin. Which one is nearer to the origin? Which one is further away from the origin? If it is this version here, then pi LED is going to be this r dot 608 is equal to 17. If it is this version here, pi LED is such that it is going to be r dot 608 is equal to 33. So what is the distance of this plane from the origin? The distance is going to be 17 over modulus of 608. This is going to be the distance. What is the distance of this plane from the origin? It is going to be 33 over modulus of 608. And we can see that this is going to be bigger than this, which means that if I were to choose this as the plane LED, it is going to be the one that is further away from the origin. It should be the one that is here. And this is the one that I want to reject because we need the plane that is, we need the plane LED, the light panel, to be the one that is nearer to the advertisement ball. So this is going to be rejected. Therefore, we are going to be accepting this. Therefore, pi LED is going to be of the form, the plane is going to be of the form 608 is equal to 17. And the question requires us to give the Cartesian version for it. it is going to be 6x plus 8z is equal to 17. Last part, part 4. In part 4, it says that this plain LED has sides of length and meters. So we are looking at this plane here. Okay, let me just do a quick sketch of it, okay? So we are looking at this plane here to have sides. It's a squarish rectangle. It's a rectangle. It's a squarish panel. So it's going to be N. And the center is going to be passing through the line OB here. So it's going to be passing through this. And we are going to find the largest possible value for N such that the panel will not touch this chord OA. So if you think about it, it is going to be this length here that we are interested in, right? So no matter how this is being positioned here, it cannot exceed this length. So I'm going to try to find this length. Is it possible for us to find this length? In fact, it is really possible, and it's quick if we were to make use of similar triangle. What similar triangle am I talking about? I'm talking about this triangle here. Okay, I'm going to try to find this length. Okay, so let me just redraw that triangle that I'm making use of, which is this here. I'm making use of, oops, it's really off. Okay, let me just draw it again. So I'm making use of this triangle here, here, here. I'm making use of this particular triangle here, and I'm interested in finding out what exactly is this length. So here is equal to, I'm going to let it be x, so I'm going to try to find x. This is A, this is B. I can find out what is AB because for the vector AB, it is going to be OB, 3 over 2, 0, 2, minus away OA, negative 2.505. AB is going to be giving me a 4, 0, minus 3. So modulus of AB is going to be equal to square root of 4 square plus 0 square plus 3 square is going to be square root of 25. This is 5. So this distance here is 5. And we know what is this distance. This distance here, this here is the distance between the two planes, which is already given to us as 0.8. And we also know what is this distance here. This distance here is OB. And just now we have actually found OB. Modulus of OB is going to be, square root of 3 over 2 square plus 0 square plus 2 square. Just now we found out that it was a 5 over 2. So this distance here is a 5 over 2, which means that I know this distance is going to be 5 over 2 minus 0.8. So now if I were to make use of similar triangle, this over this, so x over 5. X over 5 is going to be this distance, which is 5 over 2 minus 0.8 over this distance, similar triangle, which is 5 over 2. Okay, I'm using this over this is equal to this over this. So we have this. This will help me to work out the value for x. X is equal to 3.4. And now let's try to ask ourselves, how are we going to make use of the fact that this distance here is x to impose a restriction to n such that this square panel will never ever touch the chord OA? I mean, the question didn't actually tell us what is the orientation of this panel. So I'm going to go for the furthest reach. What is the furthest reach? The furthest reach will be from here, which is going to be planted here, all the way until the diagonal here, right? I'm going to make sure that this distance here is going to be restricted by this. Okay, so I'm going to make sure that this has to be shorter than this. So what is this distance? This distance is 3.4, which means that if I were to build for myself a square that will have exactly this, it is going to be a square that is going to be like this. From the center all the way until here, this is going to be equal to 3.4. Here is also going to be equal to 3.4. Let me let the sides of the square be, I've already used x here. Let me just go for y. Okay, can we find y? Of course we can. It is just by making use of the Pythagoras theorem. We know y squared plus y squared. This is going to be equal to 2 times of 3.4, which is the full length of the diagonal square. So y squared is going to be equal to 23.12. This makes y, which is a length, so I'm going to just go for a positive number. So this makes y to be 4.8083, which means that this is, if it is this particular square, then this diagonal will be touching here. So I want to make sure that this is smaller than this square. We want to make sure that n is smaller than y. So therefore, n must be smaller than y, n must be smaller than 4.8083. So what is the largest possible integer? The largest integer value of n. What is the largest possible integer value of n? The largest possible integer value of n is 4.